Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of binomial theorem. And if I talk about the question that is given to us here from this topic, the question tells us that the fourth term in the binomial expansion of expression that is given to us as root of x raised to 1 upon 1 plus log x to the base 10 plus x raised to 1 by 12 the whole raised to 6. So this is the entire expansion given to us, and we have been told that in this expansion the fourth term which is there, it's equal to 200, and we have also been told that x is greater than 1. So we have been asked to find what is the value of x here. And if I talk about the answer choices that are given to us here, the options are: first, A 100, B 10 cube, that is 1000, C 10, and D 10 raised to 4. So basically that is 10,000. So I have to figure out what is the value of x that is given to us here. So let's do that. So for that, first if I apply the idea of the nth term that we can find in binomial theorem. So if I use the idea, we know already that r plus 1th term is given by NCR, a raised to n minus r and b raised to r, where a and b are nothing but the expansion of a plus b raised to n. So n also you know here from the question that if I compare it with this, I have n as 6. So if I write that down, n is 6. Then a is basically root of this entire thing. So root of x raised to 1 1 upon 1 plus log x to the base 10. So that's your value of a, and b here is x raised to 1 by 12. So this is your values of a, b, and n. And if I talk about r also, we have been given that fourth term is 200. So if I compare this r plus 1 with 4, I get the understanding that r is nothing but 3. So I get the value of r as 3 from this expression. Now, if I use the idea, we get here T4 is equal to NCR. So NCR we know 6, C and R is 3. So if I apply the idea 6, C, 3, A raised to n minus R. So A I have with me x raised to root of x raised to 1 over 1 plus log x to the base 10. This is raised to n minus R. So n minus R means 6 minus 3. That is 3, and b raised to r. So b, if I see here, b in this case is x raised to 1 by 12. So x raised to 1 by 12, the whole cube. So I get this expansion. That now I already know that the fourth term's value is 200. So I equate 200 with this. So 6c3, if I try to figure it out, it's 6 factorial upon 3 factorial into 3 factorial. So it becomes 6, 5, 4, and 3, 2. So with that, you can cancel 3 and 2 with this 6. So you are left with the answer here 20 for the first part. Now let's solve the second. So if I write this, I get this as x raised to 1 over 1 plus log x to the base 10, the whole cube. And here you have root. So if I want to take out the root here, it's basically x raised to half. So I can write that as raised to half as my square root. And here you get this as 3 by 12. That is 1 by 4. So if I try to solve this further, I get this as 20. This is 200. And this becomes x raised to 3 by 2, 1 over 1 plus log x to the base 10 into this becomes x raised to 1 by 4. Now, when you have this idea of exponents where you have same basis, x raised to m into x raised to n, that is nothing but equal to x raised to m plus n. So what happens is your powers get added. So here also if I use that same idea and add these powers, I get this. So 200 by 20, that basically becomes equal to 10, and this becomes x raised to 3 by 2, 1 over 1 plus log x to the base 10 plus 1 by 4. So you get this entire thing here. Now if I take log to the base 10 on both sides, so taking log to the base 10 on both sides. So if I take that, what I get here is, let's see. So I get here log 10 to the base 10 is equal to log of to the base 10 x raised to this entire expression. 3 by 2, 1 over 1 plus log x to the base 10 plus 1 by 4. So you get here log 10 to the base 10, that is log a to the base a. This is equal to 1. So you get this as equal to 1. And this, if I see it as log of a raised to b, that basically I can take b ahead of log, it becomes b log a. So with that, I get this 1 is equal to 3 by 2, 1 over 1 plus log x to the base 10 plus 1 by 4, and you get this as log x to the base 10. So you get this entire expression now. Now what I can do here is I understand that log x to the base 10 is present here also as well as here also. So what I'll do is to simplify that idea, we'll substitute that log x to the base 10 as t. So let's put log x to the base 10 as t. So what I get from this equation here is t into 3 by 2, 1 over 1 plus t plus 1 by 4, that is equal to 1. So if I multiply throughout, I get this as, if I want to have the same denominator for this expression first, let's make the denominator as 4 into 1 plus t. So I'll multiply this first part by 2 both sides, and here I'll multiply both sides by 1 plus t. So I get this denominator turned to become 4 into 1 plus t for both the expressions. Now numerator, if I see here, I have 6, and here you have 1 plus t. It's equal to. So if I solve this further, what I get here is, let's see. So you get t 7 plus t upon, this becomes 4 plus 40 is equal to 1. So if I solve this further, I get 70 plus t square is equal to 4 plus 40. So from this expression, you get t square plus 70 and plus 40, if it goes there, becomes minus 40. 70 minus 40 plus 3t minus 4 is equal to 0. So if I solve this quadratic, I can write that as t square plus 4t minus t minus 4 is equal to 0. T common, t plus 4 minus 1, t plus 4 is equal to 0. So if I solve this expression further, I get this as t plus 4, t minus 1 is equal to 0. So if I equate each of the brackets with equal to 0, I get t is equal to minus 4, or I get t is equal to 1. Now I have my answers in terms of t. So if I resubstitute, because I need to find my answers in terms of x, right? So if I resubstitute log x to the base 10 as my value of t, I get this as log x to the base 10 is equal to minus 4, or I get from here log x to the base 10 is equal to 1. So now when I have minus 4 here, I can write that as log x to the base 10 equals to minus 4 into 1, and 1 I can write that as log 10 to the base 10. Or I can write this further as log x to the base 10 is equal to 1. 1 is basically log 10 to the base 10. So what you understand from this is, when you have log to the base 10 here, I can equate the part which is left out. That is, I get from here x is equal to 10, and from here I get x is equal to, if I take minus 4 in the power, it becomes 10 raised to minus 4. So you get x is equal to 10 raised to minus 4. So you get two values of x, one is 10 and the other you get is 10 raised to minus 4. But if you talk about the condition which is given to us here, the question tells us that x is greater than 1. So when x is greater than 1, it cannot definitely be 10 raised to minus 4. So since x is greater than 1, I understand x cannot be equal to 10 raised to minus 4. And when x cannot be equal to 10 raised to minus 4, the only value of x that is left here is 10. So you get this answer as 10. And if you see the answer choice that matches with the options, it is option C. So I get the correct answer for the question given to us, that is option C. I hope you have understood how to solve this type of questions, which deals with the ideas of finding the answers for values of x using the binomial theorem. So first I use the idea of r plus 1th term to get my formulas NCR, a raised to n minus r and b raised to r. Once I get that, I equated that with 200, found out a, b and n in this power expansion. And then I solved that entire thing to get the value of x using the ideas of logarithms and quadratic equations that gave me the values of x as 10 or 10 raised to minus 4. But x is given greater than 1, so that gives us the definite value of x as 10 that matches with answer option C. So C becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on 11th, 12th as well as JEE. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of questions on GEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.